Hello everyone and welcome back to the Kohi Game Engine series. Today we are going to take a look at our existing toolchain and ways to improve it. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier of support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. Okay, so in the last video, we added something to our post-build process to build out our shaders. And every time we do this, every time we add a new shader, we're going to have to add sort of all this code to this individual script. And so it's sort of formatted this way for a bash script. For the Windows script, it looks like this. For Mac OS, it's kind of similar, but not 100% the same. And I think it's time that we actually address this, because this is something that I mentioned in the very beginning, that this was sort of a temporary way of doing it, and that we need to come up with something a little bit better. Something that's a little bit more configurable, that isn't as much of a pain to add things to and extend. So what we're going to do is we are going to not get rid of these scripts, but change what these scripts call. We are going to create a new sort of project in here that we're going to call tools. And it's going to be a command line utility, at least in the beginning, that we can use for things such as shader conversion or things that are external to our engine. So eventually we'll use it to convert meshes and textures and things like that as well. But at least for right now, we're just going to focus on this aspect of it. And the way that it's going to work is our tools will basically just take a bunch of command line options that we can then use and feed in things like these file names and what process we want to run and things like that, in order to make this a little bit better than what we have now. So with that, I think the first thing that we should probably do, even before we edit any of these scripts here, is go ahead and scaffold out our new project. So I'm going to go ahead and do that. I'm going to, right next to testbed and tests and engine, sort of this top level here, I'm going to create a new folder. And I'm going to call this tools. And within tools, I am going to create another new folder called source, as we have done before. And within source, I'm going to create a new file, and we're going to call that main.c. And in fact, actually, let's rename that. Let's call this tools main.c. That way it's a little bit more obvious as to what we're actually looking at. And so we want to start off by including some things from our main engine, right? So we want to include our defines, we want our logger, and we want string, or the kstring library. We are also going to need to include stdlib for executing shell commands, because ultimately what we're going to do is the first utility that we're going to create is going to call this glslc from wherever it happens to be. We're going to wind up calling that, and then that will be called by a function we're going to use here. Okay. So the first thing that we're going to do is go ahead and we will set up our main function. So we're going to have an i32 main. It takes i32 argc and then a double pointer, or a pointer, or an array of strings rather, for our arguments, right? And so the first one of these will always be the executable itself, and then the subsequent ones will be any arguments that we pass in on the command line. And of course, this will be the argument count here. So we're going to keep things pretty straightforward, at least for now. And so since the first thing is always going to be the program itself, we are going to want to always require that at least one other parameter be passed, because this program is going to be multifaceted. So it's going to have several different modes that we can run in. And this is pretty common with command line utilities. And so we are always going to require at least one argument. And so the first thing we're going to do is say, hey, if argc is less than 2, and because the first one is always the program itself, it should always be at least 2, then it's just going to say ktools requires at least one argument. Now we're saying ktools here. It's not actually called ktools yet, but we may wind up calling it that. I just want to make sure that, maybe we call this Kohi tools. And then we can also print some usage stuff here. So we'll come back to that in a little bit, but basically another common thing for command line interface utilities is whenever you use it wrong, it usually prints out some sort of help. Or it'll tell you something along the lines of, for help, type this. And then it'll give you a listing of what all the different modes and flags and switches are. So we'll come back and address that. And the second thing is basically going to, the second argument is going to tell us what mode we want to go into. And so we are going to define one mode for right now, which is to build shaders. And we're going to define that as a couple of things. So we're going to take argv index 1, which is the second one, and we're going to say if that is build shaders or b shaders, and we're doing a string equal I here, so case insensitive. So you could pass, build shaders like this if you wanted to, or all lowercase, it doesn't really matter. So if you pass build shaders or b shaders for short, then it's going to go ahead and do that. Otherwise, we are going to go ahead and just say, hey, this argument isn't recognized, print out what it is that was passed here, and then return -2. -2 is just going to be sort of our error code in this case. You notice we'll return -1 up here for that error. So that just kind of gives us a way to say, hey, where did the program actually exit out? And then, of course, if we're successful here, we are simply going to return 0. Okay. All right. And so this is basically how we are going to structure this application. I'm going to try and keep it as simple as possible to just say, hey, look at the very first argument that we pass in, which is technically the second one, and look at that, and that'll determine the mode that we go in, and then that mode is responsible for parsing all of the switches and flags after that. Okay, so the next thing that we want to do is we actually want to declare 2 functions at the top. So we actually have a print usage here that we want to declare. So I'm going to say print help. And then we also have one that we're going to call process shaders. And this has the same structure as our main function. And that is so that we can call it here and simply return its value. So now we can just say, if we are in build shaders mode, we can return the result of process shaders. And then we can pass through just argc and argv. All right. And that just keeps things, again, pretty simple. So let's go ahead and also replace this with print help. I know we haven't defined that yet, but we will come back to that. I just want to get that in there. And then we'll go ahead and print usage here too. So we'll say print help. All right. And that is it for the main function body, at least for now. So the next thing that we need to fill out is going to be our process shaders. So it makes sense to go ahead and fill that out next. So our process shaders is basically going to require at least 3 arguments. So again, the first one is the program itself. The second one tells us what mode to go in. And build shaders is going to take a list of file names. So it requires that at least one file name be passed, otherwise it has nothing to actually process. So in that case, if our argument list is less than 3, then we have here build shader mode requires at least 1 additional argument. And of course we return -3 to give us a unique return code for that. So the next thing that we're going to do is we are going to loop through all of the the sort of end arguments there, or the remaining arguments. So starting at 3. And we're going to loop through all of those arguments one by one and process them. So we're going to set up a basic for loop like this to start at index 2, which would be the third in the array. Say, hey, as long as we're less than the count, keep going. Another thing that we're going to do is we are going to call a function called getEnv, which returns an environment variable of the given name. In this case, it's going to be Vulkan SDK. So if I go here to the terminal and I echo $, Vulkan SDK, it'll give me here the path that is registered to on this machine. You should be able to do something very similar in Windows as well. So if this path is not working for you, if this just returns empty, you need to make sure to go ahead and make sure that that's set correctly, because otherwise this command will probably fail. Anyway, so this is just a C function call to go ahead and do essentially the same thing and just store that here in our SDK path variable, because we're going to need that in order to actually process our shaders. Now, if for some reason we get nothing back, then we'll just say, hey, the Vulkan SDK was not found. So this right here tells us if invariable. Yeah, okay. Environment variable. I don't know why they spelled it out like that. Is that... I never noticed that before. I guess my brain fixed that to environment variable. Anyway, so it returns the value of name if it exists. If it does not exist, then it returns null. So we go ahead and check here to make sure that that is actually stored, and we return -4 if that is not stored or obtained properly. Okay. So the next thing that we're going to do is we are going to construct a path. So what we're going to do is we are going to get the length of the current argument, and we are going to copy essentially the last 9 characters of that. Now, why the last 9 characters? If we look at our assets and our shaders, we have .frag.glsl. That's 9 characters. .vert.glsl. That's 9 characters. Eventually, for compute shaders, it'll be .comp.glsl, or for geometry shaders, it'll be .geom, so geom.glsl. And so it wasn't an accident that I chose that naming convention. And so basically what we're doing here is we are getting the very end of the path, or the sort of double extension that exists here, so that we can use that and determine what type of shader it is we're dealing with. So once we have that, basically what we're going to do is we are going to copy off the stage portion of that from the file name. So if the end path is frag.glsl, then we're going to say stage here is populated with frag. Same for vert, geom, or comp, right? And if we add other shader types to this in the future, we can go ahead and just extend this for that. And then we're going to go ahead and 0 terminate, just to be sure that the last character here is a 0, so that we're sure that we terminate that string properly. The next thing that we're going to do is we are going to generate the output file name. So basically what that does is it grabs the end of the string minus the last 4 characters. So that would be minus this GLSL extension. So it grabs that, copies it into out file name, and then sets the last 3 characters to SPV, and then 0 terminates the last character. So it basically just takes the entire file name and changes it from .frag.glsl to .frag.spv or what have you. So we go ahead and make that that note there of the out file name. And we'll go ahead and output some info here, just saying we're processing, and then what the source is and what the target is. So we just output that information there. And then we go ahead and we build out the command that we need to execute and execute it. So the command is basically pulled straight from here. So we need to call our GLSLC, pass the shader stage according to whatever shader we actually detected, and then the path of the source, this -o, and then the path of the target. And so that is what we do here with this string format. So we have the command, which is the target string. So I've just set up 4,000 characters for that. I don't think we'll ever need anywhere near that, but it's large enough. It should always do the trick for us. So we use the Vulkan SDK path here, and then /bin/glslc, and then -f shader stage equals, and then we output the stage that we parsed. And then we output the input name, which is the argv at sub I, and then the -o, and then the out file name. And then what we do is we call this system, which executes the given line as a shell command. So this is literally the same thing as taking this string and pasting it into a terminal and executing it. And then we go ahead and get the return code from that, just as we would any other program. So if this does not return 0, then that means that we have some sort of failure. And at this point, we'll error out and we'll say, hey, there's been some sort of error compiling the shader, see the logs, and we're going to abort the process at that point. And we're going to return a -5 so that we have an error code from this so that we don't continue trying to do anything else in our post-build process. So this is how we call something on the command line from a C program. Now, one could argue that one thing that we could do here is we could, instead of using this GLSLC, we could build our tool here to directly reference the Vulkan SDK itself and do all of this in code, and we may come back and do that at some point. But I found it's easy enough for now just to set it up this way, just to get things up and running. If we want to get fancy with it later on, we can always write our own shader compiler for that. But at least for right now, this is the way I've chosen to do that. Okay, so if we have gone through all the arguments and we haven't failed on any of them, then that means that we have successfully parsed everything. So we're just going to put out some info saying successfully processed all shaders, and we're going to return a 0, which indicates success. So that means at this point, process shaders would return 0, and that would get returned here in our main function, which would also return 0, meaning success. So that is the main gist of it. The only other portion of this that we need to do is we need to fill out our print help. And so one thing that I am going to do is I'm just going to paste this out because it does have some platform-specific stuff in here. So print help in this case says if we're on Windows, we need an extension of exe to be added. Otherwise, we don't need an extension. And that is right here. So we have Kohi Game Engine tools, copyright, blah, 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 usage, tools. Right here is where it would output that exe for any of you that are on Windows. This would print that to the console. And then mode, and then arguments. Here is the mode, and then it gives a basic description of how the files should be structured, what the options are, and so forth. And then finally, of course, we obviously put the extension to fill in this right here. So that is all that print help actually does. It's pretty straightforward stuff. That's it. That's our entire tool chain. Okay. So not terribly complicated program, but it is going to reduce the complexity of our scripts. So one thing that I'm probably going to go ahead and do, let's see. I should probably I think I'm going to create the make files for this next, and then I will go ahead and edit the scripts. I think that makes the most sense. So Let's go into I guess let's see. We'll go here and we'll say new file, make file dot tools dot linux dot make. And this is actually going to be, unsurprisingly, very similar to our other make files. So all I'm going to do here is just paste this in. And at some point, we are going to be making sort of our own build system, our own C-based build system. So all these scripts eventually are going to be going away. But for right now, the most important parts of this are that it links against the engine, that the assembly is tools, and that is actually just about it. So this by itself will just allow us to go ahead and build that. So that is the Linux makefile. So since we have a Linux makefile, we are also going to need a Windows makefile. So I'll go ahead and set that up as well. So we'll go here, file, new file, makefile, not makefire, makefile dot tools dot windows dot make. And again, I'm just going to paste this in because we've already kind of been over how these makefiles are structured. So this is just the Windows version of that. Again, it just creates this ktools.exe. So that is that. In fact, that should probably just be tools.exe. That shouldn't be ktools. That should just be tools for now. Okay. So that is the Windows makefile. And the next thing that we'll want to do is come down to our build all. I guess we'll do the build all bat file first. So right here after tests, we'll do tools, and we're just going to call make against our makefile tools windows.make. So that's buildall.bat. Buildall.sh is basically going to be a copy of what's above it here. So this last one is for tests. Now we'll have one for tools, which we'll make against the Linux file. So there's that. And I guess we could probably also go to buildall Mac OS and push D tools, build. Yeah, we'll do this. I think the Mac OS build process is actually going to need some attention, but again, I don't have a Mac to test this on, so I'm kind of flying a little bit blind on that one. All right, so we have build all done. The next is going to be clean all, so we'll do the cleanall.bat first. So this is going to be basically the copy of this tests here. We'll go to here and we'll just say tools, where we're again going to call that, we're just going to call clean against this makefile instead. So that is that. We are going to then go into the Linux version of that, or the bash script, and we are going to call makefile tools Linux using clean. So that is that. And then I guess we can also do the same on Mac. So I'm actually just going to copy this. We'll say tools. In fact, looks like Mac is actually missing the test library as well. So, whoops, tests. Okay, that looks good. Again, I'm flying blind on there. So if any of you guys notice that this is wrong, please let me know. Okay, so the biggest change in our scripts is actually going to come from our post-build files. So right now we basically have all these individual shaders being called right here individually. We're actually going to nuke all that. because we don't need all that stuff anymore. And all we're going to do here is we are going to first push D into bin. So since we're doing a push D here, we're going to do a pop D down here just to make sure that we pop back out of that directory. And then we are going to go ahead and call our tools exe, passing in our build shaders. So this syntax is a little bit goofy. Thank you, Microsoft, for that. But basically what this caret right here means is continue this command on to the next line. So here we're calling tools exe build shaders, and then we're passing the path of all of our source shaders here. So all we have to do to add a new shader here is simply update this file. Eventually we'll probably want to read from some sort of central, maybe JSON file or something like that. But this is a whole heck of a lot better than what we had, so I'll take it for now. Okay, so once we've done that, we want to actually verify that the command ran correctly. So actually before the pop D, if the error level is not equal to 0, then we are going to go ahead and echo what the error was and abort the script, basically. And that should be it for the batch file. So similarly to how we've done it here for this, we are going to now do the bash script version of this. So we're going to remove all these shaders here. We're going to start from a clean slate like we did in the other one. We're going to push D into bin, which also means we need a pop D down here. And similar to the other file in between here, we are going to call tools, and we're going to pass build shaders. And this time the escape sequence to say go to the next line is just a backslash, sort of like it is in C. So that should be somewhat familiar to us. So again, we just pass the names of all of the shaders that we want to actually compile, and then pop D down here at the end. And we actually do need a error level check here. So right here, we'll go ahead and say, check the error level. If it's not equal to 0, then we will spit out the error just like we did in the batch file. This is just sort of the bash version of that. And that is it in terms of the post build. So our process is set up there as well. Now, one thing that we do need to update as well is we actually need to go into our launch JSON. And this is for VS Code users only. So for any of you that are using Visual Studio or some other editor that doesn't have this configuration, you can skip this part. But basically what we want to do is we have all these launch options in here for launching the test bed, the unit tests, and now we actually need to add a series of these in here to launch the actual tools. So I'm going to go ahead and just paste this in here because this is all stuff we've seen before. And basically all this is it provides that same configuration of arguments just through VS Code. So here we have the Windows version of that. So we have the bin tools.exe. We pass it build shaders. We pass the workspace folder assets shaders bin, or built-in material shader, all of our different shaders, right? And so that's the Windows version. This is the Linux version, which just calls the Linux version of that, and then the Mac OS version of that. And that, I believe, is actually all that we need to update. So I'm going to go ahead and do a clean. And our clean did pick up our new tools. Okay, so that's good. We'll go ahead and build. All right, and we see here that our tools built successfully. So if we have a look here in our bin folder, we now see our tools executable was generated successfully. So we know that that has compiled. So now we can go to run a task, post build, and we'll see that it looks a little bit different. We'll see here that we have our processing, and this is how we actually know that it's working. Now, if you don't believe me that this works, what I'm going to do is I'm going to go in here and get all of these SPV files, and I'm going to delete them. Okay, so those are gone. And we will run post build again. And we now see that they are all present. So we can go ahead and let me just flip over here to our run and debug. So we have our Linux launch. If we wanted to, we now have these options here to launch the Kohi tools if we wanted to debug those things. Let's go ahead actually and make sure that that works. So I'm going to go to tools main, and I am going to just set a breakpoint right here. That'll work. I'm going to go ahead and press F5 to run. And there we are. So we have our breakpoint set up here. And we have our argument count, which is 8. That seems about right to me because we have 6 shader files, the mode, and then the application itself. So yeah, that would be 8. And so we know that this is operating as expected. So if I could just continue this here, go over to the terminal, we can see that everything processed as we expect. So just as a final litmus test of this, we will go here and change back to launching the test bed, and we'll go ahead and open this up. And there we are. So we now have not really a visible change within our engine or anything like that, but we now at least have scaffolded a tool chain that we can sort of build on top of. So our process for updating our build process for shaders is a little bit easier now. There's only a couple places or a couple things that we have to do. We just add a couple strings in a few places, and that's really all there is to it. So that is going to do it for this video. Let's go ahead and get rid of that breakpoint had on there for some reason. That's going to do it for this video. Thank you guys so much for watching. Oh, I just realized it didn't turn my camera on for the whole time. So you guys actually couldn't see me this whole time. That's awesome. Well, you know what? I am not going to re-record this because it's not worth it. So I will make sure that the camera is on for the next one, or that I just do this and get rid of it. So anyway, thank you guys so much for watching. I hope you guys are learning and enjoying the series a lot. Please toss me a thumbs up if you like the video. That helps me out a lot. If you have any questions, please leave them in the comments below. Feel free to join our Discord server. There's lots of people in there that have conversations about all kinds of really cool stuff. So anyways, if you guys haven't already, consider subscribing because this engine is going to have a lot added to it over the next few months for sure. And you guys aren't going to want to miss it. So anyway, thank you guys. Have a good one. Bye.